So the title of this is using PANOS to its potential to protect Azure deployments, but the real title of this should be what I wish I knew before I worked at Palo Alto about how to use Palo Alto, right? And I've got some automation here that I'm going to introduce as well around that will help you with this. But so in way of introduction, my name is Dan Ward. I'm on the consulting engineering team for Palo Alto Networks. I primarily focus on cloud and data center, and I really enjoy automation with Palo Alto as well. So any chance I get, if I have a repeatable task, I create automation for it. I'm going to share some of that with you today. In terms of background, I ran a global security technology organization for quite a few years before coming to Palo Alto. So I was responsible for compliance, the security technology, the business management aspects of security. And so I try to bring that into the conversations that I have with customers. If any of you have spoken with me one-on-one through your account team, that's the perspective that I try to bring. So the first thing I want to talk about is when we are using Palo Alto to protect applications, the first thing that we have to do is protect the Palo Alto. And we actually have a really good document on this. It's the best practices for securing your network from layer 4 and layer 7 evasions. A lot of people don't know that this exists, but if you have not read this document, you should. It tells you what to configure, why to configure it that way, and gives you the commands that you need to execute. Yes? There is not one for 8.0. Okay. Yeah. And the same with the CIS benchmark. If you're not familiar with this, it is a guideline for best practices for hardening Palo Alto. It is not developed by Palo Alto. It is developed by an independent group of people who go through and tell you how you should configure your policy, how you should harden the password policy on the Palo Alto, things of that nature. And finally, I created a hardening script that basically does all of this and as much of this as can be automated as possible. So you can just run this, and it also sets up the other capabilities that I'm going to talk about as we go through the deck today. So first of all, from my perspective, the way that we protect applications is to see, understand, and act. Right? And the first part of that is I need to have visibility into what's happening in the application, not just from an app ID perspective, but with web applications, we actually have a unique capability at the firewall level to not only see what is going into the web server in terms of a request, but also to see how the web server is responding to that. And that response is really, really important. I'm going to show you why as we go through this. But part of that automation script that I shared the URL for earlier goes through and creates all of these custom threat signatures. And if you'll notice, they're numbered, like HTTP 100. What that is HTTP 100 response code from the server, right? So the big ones that you're going to see in terms of utilization are HTTP 200. Anybody know what that is? Come on, shout it out. There's only 12 of us. It'll be all right. Okay, yeah, that means web server knew how to respond to that request. I'm going to get into that a little bit more. These are actually very easy to set up. So custom from a threat signature perspective, a lot of people think this is fairly complicated to do. So through the GUI, I click on create a custom threat signature. I give it a number. I create a vulnerability signature standard. This is the standard, and I add a condition here. And you can see the condition is response 200. This is where I set that, right? So when I click on that, this is what I get. The context is the key piece here, the context of HTTP response code and the value of 200. So I do that for every HTTP response code and give that threat signature a name that means something to me, right? So I can look in the log now, and because I named that HTTP 200, every time that threat signature fires, I get an alert. This is informational. So I get an alert in my logs on the Palo Alto, in my syslog, so I can mine this data and analyze it. This is what that looks like. So every time it fires, I now get an alert that tells me what the HTTP response code was, right? Pretty interesting stuff, and we'll talk more about how to use this as we go through here. The other thing that we want to do is understand the URL filtering aspect. A lot of people think of URL filtering as an outbound function. I'm going to use this to protect my end users from malicious things or things that create liability for me on the internet. But when we're hosting web applications, we can use the URL filtering function to tell us what URLs are being requested from our web applications. How awesome is that, right? So I can mine that information as well. So now I know what you're asking for, and because I have all these custom threat signatures for HTTP response codes, I know how my servers responded. So I can use that to gain much better understanding of what is and is not being processed correctly by my web application. So this is how I'm setting up the threat signature or the URL filtering, just alert for every category that we support. And the automation script will do this for you as well. So you fire it against the Palo Alto instance or physical device. It works for both. And it'll go through and create all those HTTP signatures or HTTP response code threat signatures for you if you want. It will also create this URL filtering profile for you as well. In addition, this is not the default configuration for the URL filtering profile. By default, we log the container page only, and we do not log this information. So from my perspective, I want to have every piece of information that is possible to gather about how you're interacting with the web service that I'm trying to protect. So I'm going to enable as much verbosity in that log as possible. So that's what, again, the automation script does this for us as well, to configure this profile to generate the maximum amount of information about that session. And this is what it looks like. We can see, hey, I'm hosting a web app, WordPress site on Azure, and I get that context just from the simple URL that I'm generating with the URL filtering capability. The last thing that we want to do, and you need to be careful with this, do this in test first, especially if you're going into an environment that is already in production. But I want to disable log suppression. Log suppression gives the management plane the ability to count the number of times a certain activity repeats and generate one log session for it. Well, if I'm creating 3,000 HTTP 200 threat signatures, I actually want that to be tied to each individual session. And the way that I do that is by turning off log suppression, so it has to generate a log each time. And when I do, the on-box correlation of the Palo Alto is now giving me an incredible amount of information. We recently added this capability that in the threat signature, not only do we get what the signature is, but in the file name field, we've added the URL that was requested. So I don't even have to go to 2 different logs to get this information. We made it very easy to look at one place, to understand all of the logs that are being generated by this session. And by looking at one log, I have an incredible amount of context that I can correlate. What did you ask for? How did the system respond? Now, I can take this information back to the application team and say, do we actually need to service this URL request? Right? That's not valid for my application. So I can use that information to create custom app IDs for my web applications that tremendously reduce my threat profile, right? I'm hardening my security posture through intelligence about what people are asking for, how the systems are responding, anything that comes back as invalid, I want to filter that out before it actually gets to my web application, right? And so I'm able to create dashboards that look like this now, right? How much traffic was dropped and allowed? Of that traffic, what were the applications? Of those applications, what were the HTTP response codes? And here we can see this is primarily the servers knew how to deal with these requests. And what does that look like over time? So I can see the peaks in traffic. Those are anomalous. And I can see that, hey, the servers, even though those were peaks, the servers knew how to respond to that. In addition, I can see, well, what was that traffic? Hey, these attack peaks correlate directly. So even though this was valid traffic, it was also attack traffic. So we knew how to deal with this at the web server level, but it was still malicious. And I need to filter this out. So let's talk about what these response codes tell us. We talked about 200, means we know how to use this. We know how to respond to this. HTTP 404, I want to mine that data because of the traffic that's being allowed, HTTP 404 traffic is stuff that the application didn't know how to deal with. So I want to write an app ID to make sure that the request that generated that 404 error is not allowed through the firewall. It's not part of my application. Or maybe it's a broken link. I want to talk to the application team about that first just to validate. But there are some that you're going to look at and you're going to go, wow, this is an incredible amount of insight. And these are obviously not things that we support as our web application. Why are we even passing these through the firewall? So it lets you actually take advantage of the application security capability of Palo Alto in the infrastructure before you even pass that to the web app. HTTP 500, this is a big one. Anybody here been on a red team? Well, so I used to run a red team, and we loved HTTP 500 because that was positive confirmation that you have broken the application. This tells the attacker that this is the crack in your armor that they need to continue to exploit to figure out how to use that to gain access to your environment. So two things. One is, I probably don't want an attacker to ever see this. In my custom threat signature, by setting the action to reset both sides of that connection, their session just evaporates. Now, they know that something interesting happened, but they don't know what that was, and I did not give them positive confirmation that they broke the application. The other thing is, I've got a log of this. I'm going to go back to that application team and say, somebody broke your application, and here's exactly where they did it. You need to go look at this and figure out why they're able to manipulate this application to generate this error, right? And implementing that at the firewall level means that not only the application that I'm looking at is getting protected from responding with HTTP 500 errors, every web application in my environment is now protected as well. So we actually create some herd immunity at the firewall for every web service that we protect to prevent that HTTP 500 response code from going out the front door, right? So it's very efficient use of Palo Alto, so I don't have to go configure all these individual systems to do this or depend on some other part of my organization to do that for me, and they forget, and I'm the one who gets stuck holding the bag for that, right? So very powerful stuff that we have the capability in our hands with a little bit of creativity to change security outcomes significantly in our organization with a tiny bit of visibility, right? So good stuff. And what does this mean? Like, I'm talking about creating custom app IDs, but why do we care about that? Like, hey, Palo Alto has a bunch in here by default. Why can't I just use one of those? Right, so I'm going to show you what I did. I ran a little bit experiment, right? This is nothing, this is not rocket science. I created a little script that loops through, creates 3,000, in this case, 1,000 requests. It has a 15-second timeout, and it's asking for, this is actually the application that I'm hosting, the WordPress application. This is the default web page for the Apache web server that will return an HTTP 200. It actually has content there, and it's a valid URL on the web server, but it is not valid for the application that I'm hosting. This is an artifact left over from instantiation of this web server instance. And then I'm asking for something that doesn't exist, right? This should generate a 404 error. So with a 15-second timeout and this configuration, this script runs in 1 minute and 38 seconds when I don't have any app ID. So we can see high volume, right? 356 sessions per second, short duration. And every bit of it was allowed because these are all actually valid web browsing requests, right? They conform to the HTTP standard. And from a web application perspective, I'm app IDing that, but I'm not enforcing based on the app ID. So I can see that, hey, only 1 in 3 requests was a valid WordPress request, the application that I'm hosting. And the rest of it was pretty much garbage. But it was still allowed through. And we can see that here too, that, hey, 1/3 of that traffic, the system did not know how to respond to. 2/3 of it, it did, but it wasn't the right application in 50% of these cases. So we're using a generic app ID, and we're allowing these invalid requests through. So how do we fix this, and what's the impact when we do? So by using app IDs that I created, and these were very simple. Like WordPress base means that they put /WordPress/ in the URL. It's not complicated, right? WordPress admin, WP-admin, WP-content, WP-includes. That's the extent of the complexity of the app ID signatures that I created, right? And look at what it did to our attack. Most of the traffic is now being dropped. We're low volume, long duration, and way more drops. So the allows are very minimal. Of the ones that are being allowed, they map to an application that we're actually hosting. And that's all that gets through. We can see that every request is valid. These numbers and these numbers match. And again, all of the status is HTTP 200 over the duration of that extent. So it looks significantly different than what we had before with these massive peaks of them blowing our doors off with attack traffic. We're now throttling them, and I didn't even turn on IPS for this. All I did was say, this is the application that I'm trying to host and create an app ID for it, and start looking at making sure that those responses are valid. So what happens 15 seconds? What happens when I set that to 1 second, right? No attacker does this, but I wanted to see, like, what impact does that have if I create the absolute best case scenario for that attacker, right? We know that these requests are valid. We have an incredibly short timeout duration so we can reuse those ports and that memory space. And really, not a huge difference, right? We went from maybe 5 sessions per second to maybe 10, 11, 12, but this is still going to take hours for them to execute as opposed to 1.5 minutes, right? So we're significantly changing your ability to interact with my environment in an invalid fashion. What does this look like with an actual attack tool? So again, no app IDs, and I'm running SQL map, right? So this is executing SQL injections against my environment. And I can see that without app ID, I'm allowing all of this traffic. It's coming through as, again, multiple applications, saying for the most part, this traffic is allowed. And we can see that the volume of allowed applications, the volume of HTTP 200 response codes are pretty much directly correlated. So that means everything's getting through. The web server's saying, yeah, I can process this. It's definitely attack traffic. And then IDS, so this is threat enabled in alerting mode only, is screaming at me that somebody's after my gold nugget in my data center. So the question is, can I respond to this in a detect and remediate fashion fast enough? You know, I don't know how good your NOC or your SOC is, but if I were betting money, I would guess that in that 1.5 minutes, they're not going to manually insert a preventative capability in line with this communication that actually changes my outcome as the attacker. So what happens when we use App ID? It looks significantly different. On this page, the attack tool says, yep, everything's green. I'm having my way with this environment. This is fun. When I use App ID, I didn't even turn on IPS here. This is just App ID. It starts resetting a bunch of these invalid requests, right? And we can see that only the valid traffic is getting through. We're dropping a lot more traffic again. We're throttling this because if it's an invalid session and I drop it, the attack tool has to wait until it times out before it can reuse that session. So we have, again, very simple app IDs, completely changed the outcome for this attacker, right? We're frustrating the tool. We're frustrating the attacker. We're making them invest more time and resources into pulling off a successful attack. And the reality is, they're not going to invest this much effort into your organization. They're going to say, yep, something's going on here. I've got a quota to meet. I need some data that I can go sell on the black market. I'm going to move on, which is exactly what the result that we want for you. Oh, this moved. Okay. That little box should be right on the question mark. That denotes the separation between the request and the additional information that I'm passing in the query. So, you know, the thought that I had was, well, I'm going to test this to see how effective this app ID is, and if I can do simple things to bypass it, right? And I found out it's actually really difficult. Palo Alto is pretty smart about how it does this pattern match against an app ID. So I thought, hey, if I put the /WordPress/ here, that it's going to match on that, and it's going to allow me to ask for other things in the environment, invalid things, because I have the valid path in here that it should be matching on. But it actually knows the difference between what is the request and what is the query, and enforces on this part of the request only. So that means I have to somehow get this into this part of the request without changing what I'm actually asking the web server for. Like, I don't want the production app. I want to do something different. It's going to force me to the production app. So there are some interesting things I was able to do, like ask for multiple directories that match on the WordPress, but the web server knows how to deal with this. It just took me back to the default page. So even though I tried to manipulate it, it didn't work. And the Palo Alto let me through, which is the result that we want. So what happens if I start requesting other interesting things, like do the directory traversal after? It didn't work, right? We would think that this should allow us to look at one directory back from WordPress, and again, the firewall was really effective at blocking that with simple app ID, right? This is with IPS, or the threat capability turned to alert only. Now, of course, I'm getting an incredible amount of alert data happening here, and if I had that IPS configured properly, this outcome would look even better for us and much worse for the attacker. But I wanted you guys to understand why mining that data, mining HTTP 200 data, mining HTTP 404 data, and using that to create app IDs is really important. Plus, make sure that you understand that you can get that type of information about what's happening at the application layer from an infrastructure device and use that to change your security outcomes. So if I'm going to create custom app IDs, I want to be able to go back to the business and say, I'm going to implement this app ID let you know that I'm making a change. And their first question is going to say, well, how do we know that this change is not going to impact our ability to generate revenue? Having all of this data about what is valid and invalid in my environment gives me the ability to test that. So a very powerful response to that is, I've taken every valid request that has ever been generated against this web application, deduplicated it, and run it against this app ID, and it works the way that we would expect it to. Right? There is no better indicator for what is going to happen in the future than what happened in the past. So if I can use that to my advantage, I now know that I'm going to implement a successful mitigating control against an attacker without impacting the revenue stream. Right? That's the best outcome that we can hope for. And I can start running some of these 404s against it as well to make sure that I'm blocking as many of those as possible without interrupting the HTTP 200 response queries. Right? All that making sense? Awesome. So another use case, and I thought this was kind of fun. I was talking with a friend about data filtering. Anybody use data filtering on Palo Alto? What is the problem with data filtering? Needs a fixed set of characters, and when you try to create a pattern that matches against those fixed set of characters, what happens? Incredible amount of false positives, right? It's basically not useful when you're trying to match against a variable set of conditions. So DLP vendors have created this process of natural language analysis to try to figure out what's sensitive and what isn't. But you know what? In my environment, I'm talking with the business, and I know what is important to them. I know the data assets that are critical to my organization. And I'm going to insert a tag into that. I'm going to create the tag. If it's a database, I'm going to create a table that applications don't access. It's just going to be a latent table with one field, and that field's going to contain a 128-character string that I randomly generate and insert into that. I'm going to configure the Palo Alto to look for that string in a data filtering. There is no ambiguity here. It's highly specific to one string that is not likely to generate a false positive. So now I can definitively tell if that string moves through the Palo Alto with the data filtering profile. I can see that that sensitive data is being exfiltrated by this tag. I can create as many tags as that Palo Alto platform can support for different data types. So this can be, instead of data exfiltration, I can create a rule that says, this is the investor schedule for my organization. This is PII data. This is sensitive financial information, and create different tokens for those so that not only can I see that sensitive data was exfiltrated, by controlling how these unique tokens are used in my organization, I can also get some context as to what that data was. If you think about the built-in functionality of Palo Alto with app ID, user ID, all this contextual information that we generate as well, not only do I get that the data was exfiltrated, what file it was, or what request it was, I also get what application was used, who the end user was, right? Source and IP information. Did that go to, an office in the United States? Did that go to a government entity in China? My risk profile is probably a little bit different based on that type of context. So we give you visibility into that activity. We give you understanding of how important that activity is to your organization based on all this additional context that we're providing, right? It was a financial sensitive information on the CFO's laptop exfiltrated to a country other than ones that we do business with. Pretty important stuff. And we give you the ability to act on that immediately. When I ran the SOC for the company that I worked for prior to Palo Alto, this was the type of information that we were able to build into the Palo Alto to tell us what we needed to do. It wasn't, hey, something's wrong over here. It's, this is wrong, this is how bad it is, and we're going to give you enough context to immediately go do something about that. So that we had spent millions of dollars on SIM technology that was supposed to be able to do this for us. And I would walk in the morning, and the first thing the analysts were checking were the Palo Alto logs. Like, that's interesting. Why? Well, because we get way more context and actionable data out of this than we do out of the system that we paid millions of dollars that's supposed to do that for us. So, really interesting from a contextual perspective, and you know, your analysts are going to go where they get the most information that helps them do their job the quickest. And that's what, with these types of capabilities enabled and visibility context, they're going to look to the Palo Alto to get that information if we set them up for success by creating these types of capabilities. So this is how we apply the data exfiltration profile, and this is the type of log we get. So I can see that these token files have been exfiltrated, and again, I can see the application, source and destination information, country information, so all kinds of incredibly useful information. I exfiltrated this to Canada. So, you know, if I have user information here, who's involved in this transfer as well. So an incredible amount of context around how this data was exfiltrated from my organization. So to kind of wrap up, tools you can use. We have quite a bit of resources that we're creating in the company to give you better access to automation and the community of developers and people utilizing cloud. So you don't have to go reinvent answers that somebody else already knows. This is a forum for you to be able to access that community. Plus, gain access to all of the information we have on deploying our resources in different environments. And this is the one that you really want to know about. Palo Alto Networks on GitHub. We create a lot of automated deployment templates and CloudFormation templates for AWS and Azure. If you want to know how to deploy Palo Alto in these environments, go steal this, right? Hack it to your own ends, but you don't have to be the creator. You can be the editor, and it's much easier to do that. So go take, and there's some great proof of concept deployment templates and CloudFormation templates out there that show how to get a Palo Alto up and running very quickly with great instructions on how to do that. So here again is the link to the hardening script. I would love for people to take a look at that, to try it out, and I really want feedback on this. If you think that there's something else that, wow, it would be amazing if we could automatically do X, Y, or Z to improve the hardening stance of my environment, my applications, or the Palo Alto instances themselves. I'd love to hear about that. So questions? Quiet group. Yes?
You're doing custom apps and whatnot on this. Will the migration tool import that custom app ID in so that you can start hardening with your custom apps?
If you're doing custom apps, will the migration tool import the custom app signature?
So you have an environment, you have a lot of homegrown apps. You
Okay.
create custom IDs for that.
Mm-hmm.
So you're querying your Palo Alto. You're moving from a port-based system to an app ID system so that you can implement these things. Will the migration tool?
I'm not sure if the migration tool will import from an app ID. I'll have to check into that. But Typically, the migration tool, that process is happening before you have App ID, right? You're migrating a port and protocol policy over, then you're recreating App ID rules above those port and protocol rules and using those port and protocol rules as a catch-all until you're confident that you have the right App ID rules, and then you remove the port and protocol rules. Yeah, I don't know. I'll check into that. Patrick, do you know? Matt, do you know if the migration tool supports importing of custom app IDs?
Well, I don't know that I would say, I don't know the answer to that specific question, but you can use the migration tool against the existing Palo Alto Networks configuration, right? And
Yeah.
so what it's going to do is it's going to look at all of your traffic and then try and give you an app ID. It's worth a shot.
Yeah. Okay.
It doesn't care about it's looking at what's there beforehand, so it doesn't care about whether it's a custom app ID or an existing app ID. Right? So in theory, it should work. We don't know the answer, but we can find out for you.
Yeah. These guys are saying snippets might be the answer for you. Nice.
Yeah, I created a 404 just recently for a customer because they wanted to stop 404s coming in.
You can't stop a 404 from coming in. You can't stop a request before you know whether the server is going to.
No, the request would go out, and they wanted to stop the response coming in.
Oh, they wanted to stop a 404 response from coming into their organization? That's an interesting use case.
Somebody's been putting
So he mentioned that he had created an HTTP 404 response code for a customer who wanted to prevent HTTP 404 responses from coming into their organization. Interesting.
they'd seen some malicious code in the 404 page.
Okay. Had seen some malicious, maybe command and control information in a 404 response page. Interesting stuff. Okay. Any other questions? Custom threat signatures, custom app IDs, how to use that information to feed back into your environment to continually reduce your threat footprint. I don't know, is this helpful information?
Yeah.
Great. Okay. Well, thank you. I'll be around for a little bit if you want to come up and chat. Otherwise, thank you for being here at 8 a.m. on the last day of the conference, and enjoyed being able to speak with you today. Thanks.